Hey guys, welcome back. This is the second video on integration by trig substitution. Basically, in the first video, we discussed when we saw a plus sign, we were going to use a tangent, and in this case, I'm going to see a negative sign, and I'm going to use a sine. So once again, you should first make sure that it's not a U sub. And this is not a U sub because mostly all problems that have quotients, your denominator is your U in most cases, unless it's a natural log. So in that, with me saying that, this is not a U sub, okay? So what I'm going to do is I'm going to first start off by saying let x equal 4 sine theta. 4 because that's the square root of this number, sine because there's a minus, okay? So what's going to happen here is x to the third now becomes 4 to the third, which is 64 sine to the third power. In the denominator, you get 16 minus 16 sine squared theta. Dx, you have to change to thetas. So dx is equal to 4 cosine theta d theta. So that's here. So I hope that all makes sense. So once again, I just changed x to the third to be 64 sine to the third. I changed this to be 16 and so on. So let's see what happens here. So in the denominator, you can factor out a 16 and you're left with 1 minus sine squared theta. Did you know that this part here is cosine squared theta? And 16, if you take the square root of 16, you get a 4. And if you take the square root of cosine squared theta, you get cosine theta. So this is actually 64 sine to the third over 4 cosine theta times the 4 cosine theta d theta that I got from my dx. So with that being said, this and this cancel each other out. Amazing. Pause the video if you need help. You're left with 64, which is just a number, sine to the third theta d theta. You should have learned in a previous chapter that you're not allowed to add 1 to an exponent for trig. When it's an odd number, what you want to do is write it as sine squared times sine. In this case, I'm going to exchange that person for 1 minus cosine squared theta times the sine theta d theta. I'm going to let cosine be my u. That's how we do sine. So we're going to go, that's how we do sine to the third. So you got to get out sine squared. So sine, so u is going to be cosine, so du dx will be negative sine theta. Sorry, not du dx, du d theta. So now we have du over negative sine theta is equal to d theta. 64 integral 1 minus u squared sine theta 1 or du over negative sine theta. You can pause the video. That cancels with that. You still have a negative. So I'm just going to say that's negative 64 1 minus u squared du. The integral of 1 with respect to u is not x, it's u. The integral of u squared with respect to u is u to the third over 3. So you're pretty much done. You have to put back the cosine theta for the u. So with that being said, you get negative 64 cosine theta minus cosine to the third theta over 3 plus c. Negative 64 cosine theta minus. Great. The only problem is we started with x's, so you have to change them. X was equal to 4 sine theta in the beginning. here. X was 4 sine theta. So now we're going to divide to get x over 4 to equal to sine theta. I'm going to make a right triangle like I do with my trigs. I'm going to say sine is opposite over hypotenuse. And then this guy, by using a squared plus b squared equals c squared, is this, right? So a squared plus b squared equals c squared. Okay? So what is cosine theta using this triangle? Adjacent over hypotenuse. And this is going to be the same exact thing, but to the third power. Okay. 4 to the third is 64 times the 3. So all I did was I did this to the third power. Okay. Times it by the negative 64 on the outside. When you go to simplify, this hits this. You're left with negative 16. This hits this. You're left with a 3 and a positive. So if you want to be amazing and simplify it more, it would be plus 16 minus x squared to the third over 3 plus c. So I hope that makes sense. Don't worry, this 64 comes from you're cubing cosine. Cosine is this person. So when you cube it, you cube the top, you cube the bottom. 4 cubed is 64. Okay, so that's how you do trig substitution. Have a great